about characteristics today. We're going to talk about how we can describe functions. So the first is going to be domain. Domain represents the x values of a function. We can write it in three different ways depending on the situation. If it is a discrete function, which means that they are countable values and not going to be connected, we use the funky or the curly brackets with a list of the numbers separated by commas. We can use the ... to imply that it goes on, and if we know where it stops, then we could put something like a D at the end. We can also have a continuous function that includes the endpoints. Here, we're going to use the hard brackets with the lowest x value to the highest x value. We could also write it as an inequality. X is between A and B. Notice that we're using the equal signs because we're including the endpoints, and again, that's why we have the hard brackets. If it's a continuous function and it does not include the endpoints, then we're going to use parentheses. That implies that the endpoints are our boundaries, but they're not included. And as you can see in our inequality notation, we don't have the equal sign because we don't want to include those points. A range is very similar, except for the fact that it is the y values. So again, we have the same three ways to represent those functions, so take a moment and write that down. The next thing is the x and the y intercepts. So the x-intercept is the value of x when y equals 0. That's our algebraic definition, and every ordered pair or every x-intercept will have the ordered pair x, 0. On a graph, it is the point where the function touches the x-axis. A lot of times we say it crosses the x-axis, but it doesn't actually have to cross. The y-intercept is the value of y when x equals 0. This will look like 0, b. This is the point where the function touches the y-axis. The asymptote is the imaginary line that the graph approaches but never touches. We will only use this for exponential functions. We can use it for other functions, but we're not going to study those in coordinate algebra. Remember, a horizontal line has the equation y equals b. End behavior is how a graph acts as you go further to the right or further to the left. Now, this is going to look confusing, but I promise if you stick with me, it'll be okay. So again, the end behavior is how a graph acts as you go further to the right and or further to the left. If you're going to go to the left, you always start the end behavior as x approaches negative infinity, y approaches whatever that value is going to be, and we'll fill that in as we go along. For the right side or the right end behavior, it's going to be as x approaches infinity, y approaches something. Again, x goes to negative infinity is a fancy way for saying you're going left on the graph, and x goes to infinity is a fancy way for saying you go to the right. We've talked a little bit about growth and decay, but as a graph goes to the right, if the y values are getting larger, it's going to be growth. If the y values get smaller, it's going to be decay. And again, a review of continuous and discrete. Continuous are measurable values. They connect the points on a graph. Discrete or countable values do not connect the points on a graph. All right, we're going to take a break here and let's see how you're doing. You're going to go to Google Classroom and fill out the Google form based on your notes.